everyone. This is to help you with your homework for geometry with the triangles. Again, we are just doing the best we can. So if you're behind or if you've been absent, I'm going to be going over day 4, 5, and 6. So you can kind of skip ahead if you've already done some or if you kind of understand, and then you can always check back. So for the purpose of time, I'm going to show you what we want for each one and then kind of go a little bit faster as we move along. So number 1, so these are the types of theorems we have so far for day 4. So number 1, so we have an angle and then a side and then an angle. So that would be ASA because the side is in between them. And then what would we want? We would want triangle ABC. Is congruent to, well, what goes with A? E goes with A, so it then would go EDF. So again, the order matters of the letters. The second one, this is a little different. The side is not in between them. The side is on the outside. So this would be angle, angle S, because it's angle, angle, then the S. Okay, and then the triangles would be ACB. ACB is congruent to, okay, well, what goes with A? E, and then FD. Again, if you had it in a different order, that's fine, but as long as A goes with E, you see that those go together. The C goes with the F. C goes with F, looking at that angle. And then you have B going with D, which would be your the last angle. Again, just worrying about that. So number 3, what we can always say is that these are the same sides. Why? Because it's the exact same thing. It is reflexive. DB is DB. So what is this one? Oh, this is ASS. We cannot have that in geometry. So this would be called NEI, not possible. Okay? So again, we want what is the theorem, if it is the theorem, and then what are the triangles that are congruent. All right, moving right along to the next ones. Let me make this a little bit bigger so you can see them. All righty. So number 4, you can also prove that these two angles are congruent because they're vertical angles. So what theorem is this? Again, angle, side, angle. So ASA, and then write the triangles that are congruent to each other. Number 5, we've got this one. Again, this side is the exact same, so we can prove that they are, in fact, the same side. We have angle, angle, then side. Angle, angle, then side. What triangles are congruent? Number 6. What did I say about these two angles? They are vertical. So what theorem could we use for this? We could use side, angle, angle, or angle, angle, side. So know the difference between those, all right? If the side is in between the angles, then that's what you write. But if it's angle, angle, side, just know the difference between those. All right, number 7. This one's a little funky. It talks about parallel lines. So this is a parallel line, and this is a parallel line. So if we go back in time about parallel lines, well, what kind of angles are these ones? Well, those are called corresponding, and corresponding angles are congruent. So therefore, C and B are the same angle, okay, knowing that theorem. Now, what about this 5 inches? 5 inches for both of these. Okay, so what do we have? We have angle, angle, side again. All right, number 8 is something we've talked about. This is AAA, okay? So AAA, so right now, angle, angle, angle. Can we prove something with angle, angle, angle? No, we cannot. So we don't have enough information yet. Day 6 talks about number 8, okay? Number 9, this triangle with this triangle, okay? So can these be congruent? Is 50 the same as 40? No, not enough information. All right, so try number 10, 11, and 12. Gave you a few hints for those. Try those out and ask your teacher if you have questions. All right, the next ones. It is really important that you guys draw these so you can see. These are definitely on your test coming up. So we definitely want to write them down, RST. And we have X, Y, Z. And then we can look at these. All right, so I drew the triangles, and then I'm going to do 13. I want to do the same for 14 and 15, looking at the instructions. So, number 13. All right. So, they gave us this information, and they want to say, how can you prove how can you prove the rest of the information for number 13 based on what they gave you? So RS and XY. So, oh man, let me see if I can draw this again. So XYZ, so Z goes with T. X, Y, Z. There we go. Okay, so RS and XY. So these two sides are congruent with these little lines over it. That means the sides. And then it says angle S goes with angle T. Now that should say angle Y. I apologize for that. So S goes with Y. So how can we prove ASA? What else do we need? Well, we have an angle and a side. I need another angle. So in order to prove this, I would need angle R is congruent to angle X. That's what I would need to finish number 13. Okay, number 14, how do I get angle, angle, side? Okay, well, I was given a side, I was given an angle, I need another angle congruency, but that angle needs to be, so the side isn't in between the two angles. So draw the two triangles again and see what else you need. What other angles need to be congruent to prove that AAS? The last one, again, is side, angle, side. Again, draw your triangles. You are given an angle and a side, so what else do you need? So you got a side and an angle, you need another side. So draw it and figure out what two sides have to be congruent in order to prove side, angle, side. All right, number 16, looking at this information, H and L. H and L are congruent. HJ and JL are congruent. I keep talking about this over and over. These angles are congruent because they are vertical. So this means angle, side, angle. So which choice is it that proves angle, side, angle? All right, number 17. Practicing statements and reasons. So you might have to fill in the gaps of a proof in the future. So figuring out what information are they giving you. So V is the midpoint of YW. That means that this side and this side are congruent. So writing this in here because it's the given. If these are parallel lines, well, let's remind ourselves about parallel lines and these lovely angles inside. Those are called alternate interior. And alternate interior angles are congruent. So if those are it, and then I had this lovely line in here, that would mean that this angle and this angle are congruent because they're alternate interior. I can also say this angle and this angle are congruent because they're vertical. So writing in this information, then explaining the reason. Vertical angle theorem, alternate interior angle theorem, and then finally finish with the proof. Okay, so try out number 17 based on the information I gave you. Moving right along, number 18. So what information do I need in order to prove ASA? Vertical angles are congruent. Do I need that? Well, that proves angles. C is the midpoint of BE. So BE is right here. If C is the midpoint, therefore this side and this side are congruent. Sounds good. And then if I needed, do I need AD? Well, then that wouldn't prove, that would be angle, angle, side, not angle, side, angle. Little tricky. So I would need B and E. So the only one I would not need is C in order to prove angle, side, angle. All right, day 5. So day 5 is talking about hypotenuse leg. So we keep talking about that you can't prove something with ASS. Oh my goodness gracious. The exception to that is these right triangles. These right triangles, if I have the 90-degree angle, so hypotenuse leg. Hypotenuse is across the way from the right triangle, so that's the H. And then the leg can be either of these. Okay? So if you have an angle, which again is the 90 degrees, the hypotenuse and one of the legs, you can prove hypotenuse leg and you can prove that they are congruent. So for example, the first one, this would normally be ASS, but because of that 90-degree angle across the way is the hypotenuse, you can prove it with HL, hypotenuse leg. Same with number 2. Number 3, we have the angles and we have this side, but we don't have the hypotenuse. Therefore, it's not enough information. Okay, moving right along. Number 4, do we have the hypotenuse? Yes. Do we have the other side? Yes, they're the same, hypotenuse leg. Number 5, another tricky, is 50 the same as 40? Nope, not enough information. They are not congruent. The next one, okay, I have 2 angles and only this side. So don't automatically think because it's 90 degrees, it doesn't give me the hypotenuse. So I can't use hypotenuse leg. But I can use angle, side. I have this angle, I have this angle, and I have this side. Okay, so it's make sure you pay attention to what they're giving you. Okay, number 7, what is this side? That's the hypotenuse leg. Number 8. They give you the hypotenuse leg, they give you this side, and they give you the 90 degrees. Hypotenuse leg. Same with number 9. Hypotenuse leg. Look at the side, and is it across the way from the 90 degrees? Okay, number 10. What do I keep talking about? I keep talking about those vertical angles. I can prove that. These little symbols right here mean parallel lines. Okay, so then I have this side and this side are congruent because of alternate interior. If you use those, alternate interior. So therefore I have angle, side, angle. Number 11, I have this side and those 2 angles, angle, side. Again, make sure you're putting those triangle congruency. Number 12, I have angle, I don't have any angles. So what do I have? I have side, side, because this is the same side. All right, number 16, bisect, meaning that the 2 sides are congruent because it cut through it. So bisects at AC, and this bisected, therefore these 2 sides are congruent. It's saying something about perpendicular, so we have this, and then we have this side. So this is actually side, angle, side. We don't have the hypotenuse, so I can't use HL. 17, they say that these are perpendicular, therefore these 2 are 90 degrees. Q is the midpoint of PR. PR is this whole thing, therefore this side and this side are congruent. And then it says SQ is congruent to QT. So this side is congruent to this side. So we've got a 90 degree. We've got this side and we have this side. This is across from the 90-degree angle. So that's the hypotenuse. I can use HL. 18, let's get rid of that side because it's very confusing. It's not part of the triangles I'm proving. Again, what does this tell you? That tells me that it's the exact same as the other one. So what theorem are you going to use if I put that symbol? 19. If this is proven that these are congruent, which of the following is true? Okay, well, C has to go with Q. Angle C goes with Q based on the order. So CQ can't be C, can't be D. All right, now let's move on to the next one. E has to go with R. So what can I eliminate? I can eliminate B. So your answer is A. So looking at one thing at a time in your multiple choice. Okay, so try these out, reading the information, labeling the information, and going from there. All right, last but not least is day 6. Thanks for staying with me. So day 6 is about isosceles. So let's review isosceles. Hopefully you watched the videos. So isosceles triangles mean that if these 2 sides are congruent, the opposite angles are also congruent. Okay, so you can prove that with isosceles. Same with equilateral. Equilateral means all the sides are congruent, therefore the opposite angles are congruent. Okay, so let's try number 11. Number 1. So because number 1. So we can prove things based on that information that we were given. So number 1, there's 68 degrees and 68 degrees. Therefore, that means that these 2 sides are congruent. So I have x plus 12 equals 24. Subtract 12 to both sides, and x equals 12. Okay? Number 2. These two sides are congruent, therefore these two angles are congruent. So x and z are actually equal. So if I have a 90-degree angle, all triangles add up to 180 degrees. So therefore, I have 90 plus x plus z equals 180. Okay, so I subtract 90 to both sides, and I have x plus z equals 90. Well, they're the same thing. X and z are the same. So let's say I just had an x and then I substitute another x in. Well, that means I have 2x equals 90. Divide 2 to both sides, and x equals 45. Like I just said, they're congruent. So x is 45 degrees, and so is z. All right, number 3. It said that these two sides are congruent, okay? If you notice, there's no circle involved, all right? So if there's no circle, that just talks about the sides, has the little dashes. So if those are congruent because of the dashes, I'm going to make them equal to each other and solve. So get the y's together and get the constants together and solve for y. Same with number 4, 5, and 6. If these two sides are congruent, therefore this side is congruent to this side. So if this is 55 degrees, y is 55 degrees. And all triangles add up to 180. So if this is 55, y is 55, how can you find x? Number 5, these two angles are congruent. Therefore, these two sides are congruent. Make them equal to each other and solve for x. Same with number 6. These two sides are congruent. You will get a fraction. You're going to be okay. Same song and dance, folks. Okay, number 7. I don't want you to think, oh, x is 45 degrees. X is not 45 degrees. This side and this side. Therefore, the angles across the way are congruent. So this is actually 45 degrees. And if those are 45 degrees and all triangles add up to 180, how do I find x? Okay, so keep trying these out. Ask questions from your teachers. If you're in my class, you can cross out 13 and 14 on day 6 and focus on the others. So please ask us if you need help and get rocking on this homework. Have a good day.